All right, so let's talk about the exit ticket. So the exit ticket asks us to, first off, determine the type of relationship that is indicated by the following set of ordered pairs and explain how we know. Then we need to find an equation that all ordered pairs satisfy. So in the x column, we've got our input values, 0 through 4. In our y value, we've got our output values, 0, 2, 10, 24, and 44. And from there, we need to figure out where our constant difference is. Remember, our constant difference is going to tell us what type of function we have. So first off, we've got 2 minus 0, which is 2. We've got 10 minus 2, which is 8. We've got 24 minus 10, which is 14. And we've got 44 minus 24, which is 20. If we continue that, that's our first difference. Our second difference would give us 8 minus 2, which is 6, 14 minus 8, which is 6, and 20 minus 14, which is again 6. This is our second difference. So we notice constant differences here. It's going to mark it with a C. So our second difference is constant, and if we look back at our notes, I've cheated and copied and pasted the notes here, so it's easy to look at. But right here in example 2, we see that if the second difference is constant, the function is quadratic. So the second difference is constant, which means that the function is quadratic. So that's exactly what we're going to write. The second difference is constant, so the function is quadratic. Then it asks us to find an equation that all the ordered pairs above satisfy. And this is like example 4 from our notes. So we're asked to find an equation that all ordered pairs above satisfy. First off, our ordered pairs just means our x values and our y values, our coordinates. So 0, 0, 1, 2, 2, 10, 3, 24, and 4, 44 are our ordered pairs. And we know that our function should look like y is equal to ax squared plus bx plus c. So we know it's going to look like that. First step that I showed you in example 4 was to find the end value. In this case, the end value is c. So step 1, we're going to find that end value, which is c, by plugging in 0 into x. If we notice, if we plug 0 into x, we also got to plug 0 into y. So we're going to do 0 is equal to a times 0 squared plus b times 0 plus c. This goes away and this goes away, leaving you with 0 is equal to c. Since 0 is equal to c, we can move on to step 2 and find a. Step 2, find a. I don't need to write that down. So if we look at our table, you might be thinking that I only gave you one table here, but I didn't. If you look right above it, or in your notes rather, we've got the quadratic table, and this is what we need to be looking at every single time. So here, same idea as previously, we want to find a all by itself in our table. If you notice, that's super easy to find. We've got a 2a right here. A is all by itself. There's no b value, there's no c value there. So all we need to do is come down here, and we can look and say that 2a is equal to, that was the first item in the second difference column. First item in the second difference column is 6, so 2a equals 6. So 2a is equal to 6. We divide both sides by 2, and we get a is equal to 3. So very quickly, we've got 2 of our 3 items. Step 3, the last step is we got to find b. So we're going to come back up to this table here. We're going to look for where we find b by itself. Just like before, we already have our a value, so this a plus b is actually just b by itself. And this is the first item in the first difference column. First item in the first difference column. First item in the first difference column is 2. So I can say that 2 is equal to a plus b. 2 is equal to a plus b. And a is 3, so we can say 2 is equal to 3 plus b. And subtracting 3 from both sides, we get negative 1 is equal to b. So our final answer here is y is equal to 3x squared minus x, and then c was 0, so we're done. 3x squared minus x.